So this session is called Mythbusters. It's basically a repeat. Nobody cares about that. It's a repeat of a very popular session that I've been doing for the last 2 or 3 years, and it's been updated for SharePoint 2010. It's actually the first time I've done this for 2010 in public. These are the things we're going to cover: topology, service apps, authentication, global deployments, scalability, and then we'll touch on the software boundaries towards the end. And I'm reasonably flexible about what we can talk about here. I have some slides, and I have a machine up and running that I'm going to show you a few things on. But I'm pretty flexible. If there's stuff that you're interested in this space that you want to talk about or discuss, then feel free to fire questions at me as we go. So the first area is around farm topologies. In SharePoint 2007, there was a lot of confusion around topologies. The documentation on launch wasn't particularly clear. There was a lot of misconceptions in this space. And as you've probably gathered from the rest of the content earlier in the week, SharePoint 2010 gives us a significantly wider scope for our topologies. We can have much more complex topologies. We have much more flexibility, and that's a good thing, but it's also a bad thing because it's more to think about, it's more to explain to your customers, and so on and so forth. It's also very true to say that for certain services, there may be a recommendation from Microsoft right now, there might be a recommendation from the other speakers at the conference, there might be a recommendation from me that says you should deploy this particular service application in this way, and these are the considerations for scaling it out. But the reality of the situation is, the harsh reality of the situation is, despite the reasonable number of rapid deployment customers, we don't actually know how this is going to play out yet. And an example from the past is the Excel calculation services piece of SharePoint 2007. On launch, the product group made a strong recommendation that you deploy the Excel calculation services on a dedicated application server. Not a bad recommendation, generally speaking, but it was kind of hedging their bets there. Today, the recommendation for 2007 for that particular piece, and still true for 2010, is if you are just doing rendering of spreadsheets and you're not doing expensive calculations, then you actually deploy that service on the web front ends and you'll get better performance. So there's a difference between the recommendation on the day of launch of the product and the recommendation 3 years down the line. And it might seem obvious, but that's based on experience in the field with the product. So these things change over time. And last time around, Excel services was brand new. It was the first, it's the V1, if you like, of that product. So we have a lot of V1 service applications in 2010. Things like Visio services. We don't actually know how customers are going to deploy that for real yet, because the software is only just becoming available now. And so over time, these kind of recommendations will change around a little bit. But we still have some constants in the world of SharePoint. The first one is this term that I'm sure you're all familiar with called web front end. And unfortunately, this is a kind of hangover. If you were at the party last night, you probably understand this one. From the previous versions of the product. There is actually no role called web front end. It's a marketing term. We have a service called the SharePoint Foundation Web Application Service. And when you install SharePoint, you join a machine to the farm, this guy is going to be running automatically by default. I'll just switch over to the demo box and show you that. It's fairly straightforward. Here we are. This is services on server from central administration. And it's this guy here. It used to be called, obviously, Windows SharePoint Services Web Application. And this service is not a Windows service. It's just IIS, basically, and the timer job infrastructure as well here. And this guy is responsible for managing the web applications that you create, making sure the settings are applied. So when you join, say you've got a farm with 2 web front ends, and you join a third one in, this guy is going to make sure that the configuration settings are applied to the third one. So this is actually the service that, in reality, is what's often called the web front end role. There's some others as well. By default, I've joined this machine to a farm, but I haven't run the farm configuration wizard. I've created also a couple of other service apps, but you can see the ones that are started here highlighted in green. Ignore the one that claims to Windows token service. But this, we have the incoming email here. We obviously have the timer service. These are the ones that effectively make up that web front end role. So if you can, when working with customers, we're not doing that, try and avoid using this term because it causes confusion. It would be much better just calling it a web server. Unfortunately, the term will hang around. It will still be used in TechNet and all over the place as well. But it's inaccurate. And then we have all these other services, and I'll come back to some of these later. On the left-hand side here, I'm talking about SharePoint services. So things like the screen I just showed you, services on server, things like Excel, Visio, and so on. We also have some things like content deployment, which also have the ability to specify machines in the farm for a particular operation. And content deployment has an import and export server. So again, if we switch just briefly back to this machine, oops. In between C and D here, I don't have any content deployment service per se, but if I went into the content deployment settings, and I'm praying this works because I haven't actually tried this. You can see here I can specify an import and export server, and we also have similar options for things like document conversions as well. So it's not just the things that show up in services on server you need to think about from a planning your farm perspective. If any of you remember SharePoint 2003, there was a problem with that product in so much as if you deployed the farm topology in a manner that Microsoft didn't like, you get a little red warning in central administration saying your topology is unsupported. It would still work, but you couldn't back it up, for example, which was a kind of minor detail. And then with 2007, customers didn't like that because there was many topologies available to you in 2003 that worked just fine and were entirely appropriate, but because Microsoft hadn't tested them in their own labs and so on, they weren't going to support them. And so there was a big customer pushback. And with 2007, they had this marketing spiel that said there are no topology restrictions in 2007. But of course, the reality is there are actually plenty of restrictions on the topology in the real world. You can only have a single index server per shared service provider, for example. You weren't able to have high availability and redundancy for the search service in SharePoint 2007. And again, this remains true for 2010. We have many more services. We can do extremely complex farm topologies. But there's still restrictions on what is sensible to do. This idea that you can just keep adding machines into the farm and have linear scalability. So if you have free web front end, or see, I'm using the term myself, you have free web front ends, you add another free, you get double capacity, isn't the case because the SQL Server at the back end can only service so many machines or clients, which is the other servers in the farm. The good news here is the topology models we've had from the past still remain appropriate and workable. How many of you here have got a medium server farm? Yeah. so it's about half of you. That is still the sweet spot of the product. We're kind of jumping on the back of 64-bit and a few other bits and pieces, improvements in SQL Server, improvements in the way SharePoint does its stored procedures, and so on. So we're getting more bang for buck with the medium server farm. But those topology models, such as the medium farm, remain appropriate for the vast majority of deployments, and it's the way to start. It's the best start point for your topology. Now we actually have redundancy for the index or crawl components. You could actually change that medium server farm round, and instead of having 3 machines, so you've got 2 web front ends, 1 index server, and then your SQL server, so 3 SharePoint machines, you can actually now just do it with 2 SharePoint machines and just have all of the services running on both machines. If it's simple, you'll be able to service the same kind of number of users in that environment. Then we have this idea of load balancing, and it's deliberately in quotes on the slide here. So we have our query component, the search query component, and this, generally speaking, in that medium server farm example, is going to run on the same machine as the web application service. But there's no load balancing going on here. There was some Visio diagrams shipped back in 2007 that had a little picture with, you had 2 web front ends, they were load balanced by network load balancing, and you had 2 machines over here that were running the query server, and they were load balanced. But you don't have to load balance these other roles. It's a software pseudo load balancer that deals with routing requests to the appropriate server. And there's a proxy component that lives in the web front end process. And it's that guy understands the load balancing scheme of the service it's talking to, and it's that guy that determines which machine to send the requests to. So you don't have to do anything with your infrastructure to load balance these services. Now the service dictates how it does load balancing, and the examples here are deliberate. Our search query is fairly straightforward. It's going to send it to the one that's the same machine if it's installed on the web front end. Otherwise, it's just going to send it to the one that's it's going to do it in a round-robin fashion. Excel Services is different. By default, Excel Services is going to do it based on the URL of the workbook that's being accessed. So the implementer of the service decides how to do load balancing. It's a horrible term, but there isn't really a better term for it because it's really a proxy that's doing this work. Talk a little bit more about search. How many of you were in Neil Hodgkinson's sessions on search earlier in the week? Okay, good. Some of these recommendations from the community, shall we say, are out there, and they're still being pimped, if you like, for 2010. The first one is to make the crawl server what's known as a dedicated crawl front end. And the idea here is that we don't want the crawler to be going outside the farm through the load balancer into the web front ends, because that's going to impact end users. It's going to, when a crawl is happening, the response time for normal users is going to suffer. And there's also the idea that going across the network is going to increase the crawl time itself. So we have an option in central administration to specify a machine as a dedicated crawl front end. Now, the concept is a good idea. You want a machine that is the index point, but you definitely don't want to check that tick box in central administration, because that tick box is going to basically break your hosts, break your network infrastructure on the server that you're running it on, that you select. And if the machine has more than one network adapter, it's going to break it. It's going to break it horribly. So you never check that tick box. So you just basically install or start the web application service on the machine that you're running as the crawl front end, and you manually modify the host file on that machine. And the reason for this is the code that is in central admin doesn't understand multiple network adapters, and it will break your configuration. Now, the other point here is it can be a good idea in a small environment to have your web applications running on the indexer or on the crawl server, because then you're just going to the local machine and it's going to be quicker. The problem is, once you get to a certain scale of either the number of web applications or the size of the corpus, you want your indexer to have as many resources available to it as possible. And if you're loading up a bunch of web applications, they're all using memory, they're all using CPU, you can saturate the resources on that machine. Now, because we can have multiple crawlers and we can have partitions and a bunch of other crazy stuff that I don't really understand yet around search, that Neil knows about, this is kind of becoming less of a big deal. But in a medium farm environment, you've only got so many machines, so you're forced to look at these options. But carefully consider if you hosting of the web applications on the indexer, because the indexer needs the resources to do the crawl. So you don't want to be soaking them up. And the hop over the network is greatly overplayed. If you have gigabit Ethernet in your server farm and you have a correctly configured farm in terms of security and network communications, that hop over the network is not going to have a significant negative impact on crawl times. It's a myth. The other one here is where to host the search query component. And there's a very common recommendation to always run this component on the same machine that's running the web application service or the web front end. Now, we have this thing called continuous propagation in SharePoint. So if you have a large content index, say you have 36 terabytes of content in SharePoint, you've got a pretty big index. That index is going to be replicated, or, well, not replicated, sorry, propagated to each machine that's running the query component as well. So you need however many machines you've got that are running that, plus the indexer is how many copies of the index you've got. And it obviously takes time and storage. Storage is the big deal here, right? Because if you've got a large corpus, your index is probably on some form of network storage, SAN or similar. And those SAN slices can be pretty expensive. So if you've got 8 web front ends, which is a stupid idea for other reasons, but if you've got many web front ends, then you have 8 slices of SAN to store this index. You can't share it. You can't have this stuff in one location. And the other thing is, it very much depends on the usage patterns. A common theme of mine is trying to design these things up front and estimate how it's going to work in the real world is almost impossible. It's a capacity management discipline. If you have a scenario where 80% of your usage is collaboration and nobody really does much searching, then you don't need that many search query servers. On the other hand, if you've got a 50-50 environment, so 50% of the usage is collaboration, 50% is people searching for stuff, then obviously you need enough query servers to handle those requests. Okay, so moving on to service applications. You've probably noticed it's a bit of a theme. Everybody's going, wow, service apps, they're wonderful. Aren't they so much better than shared service providers? And I'm hoping that, I'm not directly addressing anything that somebody said this week. If not, I'll have a word with them later. But these are some of the common misconceptions around service apps. Microsoft haven't done a particularly great job thus far of explaining these things in terms of the technical detail. And service applications are fundamentally an idea. They're a logical thing. There is no direct relationship between a service application and bits on the machine. Different service applications have different physical components. So the first one is that they're hosted by the SharePoint Web Services IIS website. If you remember 2007, this is called Office Server Web Services or something like that. Now it's just SharePoint Web Services website. I'll show you this in a second. The other very common misconception, which is hurting already, is that service applications are deployed to an application server. And that's not true at all. The service machine instance is deployed to the application server. The service application lives on the web front end. Another classic one which we tend to chuckle about is people say, oh, service application, it's just a giant web service, just a giant WCF. Or if you think about something like search or user profile import, you know, there's a lot more to it than a WCF file. There's also this idea that these service applications magically provide load balancing and scalability. You know, you can, so the crazy widows next door will create a custom service application, right? And the idea is that the idea they're being solved is if they do that, then they're going to magically get some load balancing for free. They're going to get some scalability for free, like it's a checkbox that you do on the project. And of course, the service application implementer, like I mentioned before with Excel services, has to decide how they do load balancing. Right? We have some infrastructure plumbing, the connection of the service connection or the proxy that allows the consumer to talk to the back-end service. But how that back-end service deals with load balancing is up to the implementer of the service. So we don't, SharePoint is not doing some voodoo magic to provide scalability and load balancing for these things. It's also a misconception that service applications make delegating end-user credentials a snap in SharePoint. It doesn't actually change what we have to do here. There are some examples where things are a little simpler, i.e. there's less steps. But we're not, the service application infrastructure, whilst it makes use of claims identity, is not doing anything extra for us here than we have before. And service applications, I'm sure you saw Steve's session where he talked about publishing services across farms. Whilst we have the capability, it doesn't make it simple. We still have to plan our certificates and our trusts to make this work. So the reality is, it's actually significantly more complex than we have before. Now, you probably can't see this diagram very well. Apologies for the draft. This is an example of the user profile subsystem in SharePoint 2010. If you're into this, I'm doing a talk on it later in detail. But this is just to get across, this is a complex service application, and there's many components. At the top there, we have our web application, and within the web application process is where the proxy is deployed. This is how clients or applications communicate with the service application itself, which is in the middle, the user profile service application. And that guy has actually two Windows services. One Windows service, Forefront Identity Manager, one called Forefront Identity Manager Synchronization. And this is the stuff that actually does the work, right? So a couple of Windows services. They have their own configuration, they have their own databases, and so on. And we have this user profile service. This is just a web application which is responsible for surfacing the profile properties in the application. So you can see here, for what might appear to be reasonably straightforward, we have two Windows services, a couple of web services, and 3 databases. And we have a similar diagram, although it's too big to fit on a slide, for things like FAST and for search and so on. Not all service applications are like this. If I switch to the demo machine again, And we'll talk through some of these examples. So here's the services on server. And some service applications have a direct dependency on one of these guys, and some do not. Is there a matrix on the internet that details this? Right now, the answer to that is no. There will be one very soon, which is going to give you like the gory details of this. So just show you a couple of things. Here's our SharePoint Web Services IIS website. This is installed on every machine in the farm. On this machine, I have the two pseudo service applications here, the STS and Topology. Those are required on each machine, and those are deployed by the SharePoint configuration wizard. And you'll also notice one here with a really easy to remember name here. And if I click into this guy, it's actually the metadata web service. So this is the managed metadata web service. So this isn't the service application. If I switch to the central admin here, you can see I've started this already. It's this one here. And if I go ahead and start, let's pick an example that's not going to blow up. Excel calculation services. Let me start that. He says. Okay, that's started. And if I refresh here, I should see, eventually, that's not very good. Okay, it's saying it's, yeah, that's a bad example actually. Let me start the Visio graphics service down here, this guy. And you'll see that nothing's actually showing up in here that references that service. If I then go ahead and go to the service applications, and by the way, you shouldn't be running the farm configuration wizard ever. Right? Unless you're just doing a hack and slash machine that you want to play around with things. The farm configuration wizard, you know, it comes up after you've installed the product and it says, do you want me to go ahead and make a mess of your box for me? Or, you know, I know what I'm doing, I'll take care of it myself. You should always take care of it yourself. And I'll go ahead and create a new Visio graphics service. And I need to give it a name and an app pool, so we just call it Visio SA, and we'll create it in this app pool. And I was expecting it to be a little quicker than that. What I'm actually going to do, I don't trust that. I'll go back into it. Okay, good. So now you can see that we have another application in here with another memorable name. And there's our Visio graphic service component. So that's the endpoint. That's the service application endpoint that clients will call, or the proxy will call. So you won't have these on every machine in the farm. You'll only have this on the machine where you've started the service instance. And obviously Visio, well, not obviously, Visio hasn't done anything. It hasn't started a Windows service for me. It's just a very simple in-process. Simple's being kind of harsh on the team that built this. It's actually not that simple, but it's a in-process component. Whereas something like user profile synchronization has a bunch of other components, as we saw on the diagram. I'm not going to start it now. If you want to see that go wrong, come to my next session. But in Windows services here, you can see the one highlighted is the search service. Dependent on our farm configuration, it's going to change this from disabled to started and so on and so forth. And if we go to here, you can see we have two services called Forefront Identity Manager. Those are the things that do the user profile sync. And if we go on the file system into the SharePoint server location, we have a folder here called Synchronization Service, and these are the bits of that service, and we have the client application here and so on. Now, I haven't set this up, that's why that fails, but I'm just showing you that these are the things that are doing the work. So there's a lot more to it than perhaps the vendor is explaining, and things can get pretty complicated, dependent on the scope of the service application itself. And how many of you here have got problems with custom code that you've been asked to deploy on your farms? Yeah. So that's today, okay? That's web parts, custom features, maybe some timer jobs. Think about how many more problems you're going to get if some development company or people in your company are giving you a custom service application, and it has the same traits as the custom code that you're working with today. It's pretty important that you get all custom code right, but it's absolutely critical to the health of your farm that service applications are deployed or implemented in the right way. So be suspicious if somebody says, here's our custom service application. First of all, as an IT person or as an infrastructure person, as an architect, make a value call. Should it actually be a service application or not? And make sure you do some rigorous QA on this. Also do the same for vendors, right? So for ISV solutions, a lot of the vendors will be changing their software from the way it is today into a service application. Be very cautious with these guys. You should be cautious with the ones Microsoft are giving you as well, right? It's not just everybody else that's at fault. Okay, so moving on to authentication. We have some of the same misconceptions with 2010, but we have some new ones. And the big new one is claims identity is being pitched as the solution to world hunger, basically. It solves all our problems. Now, the reality is far from that. Authentication will remain probably the most challenging aspect of enterprise deployments of any web application, SharePoint or otherwise, for the foreseeable future. Claims does not mean Kerberos is dead. You still will need to configure Kerberos if you want to speak to back-end systems like SQL Server and analysis services and reporting services and CRM or some custom line of business solution via BDC. Because for claims to make Kerberos go away, A, would be patently ridiculous, but also it would depend on those back-end services supporting claims. And SQL Server today does not understand claims identity. It is not a claims-aware application. Neither is analysis services, neither is reporting services, neither is CRM, and so on and so forth. So at some point, whilst SharePoint uses claims and it makes it easier to delegate authentication inside the SharePoint world, most people are doing authentication delegation because they want to access some other system outside SharePoint. And at some point, you have to translate the claims identity into a Windows identity so that you can pass it on to the external system. And to do that, of course, you need Kerberos. So in the SharePoint environment, we have an implementation of a thing called the Claims to Windows Token service. And we've seen this already if we were paying attention. It's in here. This is stopped at the moment. If I wanted to use this environment to speak to analysis services, I'd need to start this guy. And this guy is going to take my claims identity in SharePoint and create me a Windows token. And then I'm going to configure Kerberos on analysis services, and I would be able to access my workbook data as the user that had signed into the application. Now, there's nothing really special with this one. There's no SharePoint magic, really. It's a bit of a misnomer. If I start this service in here, it's simply going to start the Windows service, which is part of the Windows Identity Framework, and I think it's called Microsoft Geneva Claims to Windows Token Service, which is the same thing you would get if you installed Windows Identity Framework on a server that hasn't got SharePoint on it. So we still need Kerberos in many scenarios, and Kerberos is still the most appropriate choice for doing authentication. If you're in my claims session, I said basically that claims is about authorization. There's some other subsystem is doing the authentication first. You can do claims with Kerberos, right? There's still valid security and performance reasons why you would use Kerberos. And claims also doesn't give you single sign-on. It gives you a token of claims that you can use to pass to other systems, and it can reduce the amount of authentication traffic. But it doesn't do single sign-on because there is no system on Earth that does single sign-on, unless you're talking about Active Directory, and everything's Active Directory integrated. Then that's single sign-on. But otherwise, there is no product you can buy, there's no service you can buy that does this. Claims is not the solution to single sign-on. Another classic one, I just enjoy this one because I know the person that made the recommendation. If you have a large environment, there's this old wives' tale that for every 4 web front ends you have, you need an additional domain controller to be able to service all the authentication requests. And this is basically a joke. It came from the original recommendation from way back in 1998 from the Exchange team. It said for this number of Exchange services that you add to the environment, you need these additional domain controllers. But it very much depends on what you're doing. If you're doing Kerberos, you'll need less domain controllers than, as a generalization, you'll need less domain controllers than you will if you're using NTLM, because there's less impact on the domain controllers when you're using Kerberos. It also depends on the use case, how far away the users are, and so on. I'm not saying you don't need additional domain controllers, because that's a very common issue with customer deployments. So they have an existing Microsoft server estate, they deploy SharePoint, and people moan that it's slow. You go in, you do a health check. There's actually, surprisingly, nothing wrong with the SharePoint farm. But the domain controller, they didn't add any more domain controllers. Obviously, there's a lot more authentication requests. So you do need to factor this into your planning, but this whole idea that you need one domain controller for every 4 SharePoint machines is ridiculous. More importantly is where the domain controller is. So I had a customer who had 2 data centers, one in the southeast and one in the Midlands. This was a hosted environment, right? They'd outsourced the hosting to, well, I can't tell you the company name, one of the usual suspects in hosting in the UK. And the SharePoint farm was in the southeast, but the domain controller was in the Midlands. All right? So they're on a different subnet. It's going over the WAN. That was why it was slow. So you should have a domain controller that's local to the farm. Okay, so it's on the same subnet as the farm on a high-speed gigabit network connection. Okay, so moving on to a little bit about global deployments. And there's a couple of people out the back there that are selling solutions that do this. But there's a very common misconception that SharePoint doesn't do geographic distribution. The idea here is you would have a data center in Europe, a data center in Asia, a data center in America, and you have one farm that's, that's spread across these different environments. Now, SharePoint isn't supported over the WAN in some scenarios, but there are many solutions to this problem. The fundamental thing here is lots of people want to deploy SharePoint in the same way that they deploy Exchange. They go, well, Exchange has got large data sets and it does replication. You know, why can't SharePoint do it? It's a very common kind of request, but you really need to think about actually what SharePoint's doing. It isn't a mail system, and that's why it doesn't fit this model. It doesn't work well in this space. You don't need all of the content replicated to all of your data centers. It doesn't make sense. If you're in a situation where you're kind of being forced to do this for political reasons or for, you know, Microsoft sales have been in and said, yeah, we can do that, no problem, and the customer wants to do it, there are plenty of options to make it appear that it works this way. And some of the vendors outside, I think we've got two here this week, Synergy and RepliWeb both have solutions in this place, in this space. But SharePoint doesn't do replication. To do replication, you effectively have one of two options. You either go down the route of content deployment type idea, or you go down the route of an event handler on a list that writes to a database, packages stuff up and sends it over the wire and does the reverse on the destination. And if you really want geographic distribution of SharePoint, you shouldn't be deploying it yourself anyway. You should be going to SharePoint Online, because that is geographically distributed by the, you know, and it's dealt with by the Microsoft Data Center capability. So if you really want geo-distribution for speed reasons to, you know, improve end-user access speed, A, you need to invest in network links, but B, you really should be seriously considering SharePoint Online, especially now that SharePoint Online is a full capability. You know, there's less restrictions in the service offering there. If you're doing geographic deployments, then you are not short of money, so the whole SharePoint Online costs too much argument is kind of mute, because it doesn't really matter which solution you buy to solve this problem, it's going to cost more than SharePoint Online. With respect to working over the WAN, there are some improvements in 2010 that make some of the service applications more efficient over the wire. But the problem here has got nothing to do with SharePoint. If you've got a slow network link, you've got a slow network link. There is nothing SharePoint can do for you. You could look at web accelerators, you could look at SSL accelerators and various other devices that deal with compression. These are boxes. You put one in your farm network and one in the client network. And some of those can work well and help in this situation. But fundamentally, this isn't a problem that SharePoint should solve. You know, we're not going to see, you know, the geographic availability or the WAN accelerator shared service application in the future, right? This is not... There may be some guys in the team that would like to build that feature, but they shouldn't be doing it. It's something that is dealt with at the network level. A couple on high availability. First one is web gardens. There's a couple of blog posts out there by famous people that say you should turn on web gardens. You shouldn't. They are 100% unsupported. More importantly, they break things. If you turn this on, it will break your blob cache. It will also break some of the other caching and managed resources in SharePoint as well. I haven't done extensive testing on this. I may spend a little bit of time on it in about a month or so to see which of the new shared service applications resources break when we turn this guy on. But you shouldn't be doing it. If you're not familiar with this, this is in IIS. For an application pool, I can go into advanced settings here, and I can change the maximum worker processes value. So this is the number of W3 WP.exe that's going to be running on the machine. And you could say, oh, well, you know, I could change this to be 4. And then, you know, I'm making use of all that memory that HP forced me to buy, that my customer thought was a good idea. But it's not going to give you any bang for buck, it's not going to really improve your performance, and it's going to break things. So don't do that. Very bad idea. There is one use case on if you have very limited 32-bit infrastructure running 2007. There are some cases where you can use it as like a sticky plaster over a problem. But if you're on 32-bit, you've got a welder hurt. You need to get off 32-bit. That's the solution to that problem. This is only a sort of temporary workaround, if you like. The other myth was that we should do this because when we run SGS ADM on the machine, it ties up the worker process, and that was just completely made up, completely false. Having more worker processes doesn't give you more threads on the machine to execute code. The next one, single farm can host hundreds of web applications. No, don't go there. 20 is a reasonable number. 64-bit, oodles of memory, doesn't make any difference really here in this space. You can have, obviously if you've got 64 gig of RAM in your server, you can have a few more than previously, but you still can't go to hundreds. If you want to do this kind of scenario, you should be looking at multi-tenant deployment and host name site collections. SharePoint loves RAM. It loves it so much, it doesn't even give some of it back when it's finished using it, often. So when we create a new web application, if we do it in IIS, we create a new website, it's going to use, 200 meg, something like that. If we do it in SharePoint, it's going to use 800 meg. And that's just an empty one. I'll come back to the request routing. The other idea is to have, say we've got 4 web servers, and we want servers 1 and 2 to host applications 1 and 2, and servers 3 and 4 to host a couple of other web applications. Well, you can't do that with SharePoint. By default, every machine in the farm that's running that SharePoint Foundation web application service hosts all web applications. It has to work that way. You can do some tricks with DNS or request routing, which is an add-in to IIS, or some third-party solutions that allow you to direct end-user requests for applications 1 and 2 to servers 1 and 2. But you have to consider things like patching and upgrade and the timer job infrastructure. You need the applications, the same 2 web applications running on server 3 and 4 over here for those things to work. So don't be disabling them on these machines, because the next time the web application provisioning job runs, it's going to overwrite your changes. And that's a good thing, because that's the whole point of having a web application provisioning engine, right? That's what SharePoint is. Forget all of that, Web 2.0 stuff, all that collaboration stuff. Basically SharePoint is a provisioning engine at its core. That's its main purpose from a systems perspective. There is nothing wrong with multiple farms. It's better to have 2 small farms than it is to have 1 uber one. It's easier to manage. It doesn't cost you any more. There's no licensing. You don't pay a license per farm, right? You pay a license per server and for the users. So it's better to have distinct farms rather than, if we're in the scenario where we want different machines to service different host name requests, you're either looking at multi-tenancy or multiple farms. And of course, SharePoint Online Dedicated, how do they do it? Well, you basically get a dedicated infrastructure, right? Dedicated farm. Might be on a virtual machine, but you don't care about that. It's there is nothing wrong with having many farms. Server groups, you may see a thing called server groups in some of the Visios that Microsoft have produced for 2010. There's no feature in the product. It's a logical concept. We can use service connections or proxies to kind of semi-do this, but again, we need the first bullet. We need DNS or request routing to actually implement this. the idea of server groups is entirely a logical concept. There's nothing in central admin or PowerShell that we can configure to turn this on. Okay, so that kind of goes nicely into my whole pitch on topology. I often get asked to come in and do somebody's farm architecture, design their SharePoint for them. And it's usually the situation that the customer has really no idea around the things, the topology considerations and so on. And they don't really know how they're going to use SharePoint because they're deploying SharePoint to replace, other systems, usually a combination of other systems. But they have a budget, right? They've got a magic number, which is how much they can spend on software and hardware and so on. And say, right, this is our money, go off, speak to the business, do all of the fact-finding and so on, and then come up with a design. And then there's a project to actually implement that, right? So they hire people, come in, they build the machines and so on and so forth, and then there's a go-live date when they turn it on to the end users. And SharePoint isn't like that. SharePoint has to be an ongoing thing. The topology you design is not, initially is not going to be the ideal topology for 2 years down the line. You don't actually know how SharePoint is going to be used in your organization until the organization starts using it. Nobody can foresee the future in this space. Especially now with 2010, there's so many new service applications. You need to be thinking about having a rolling ability to change your topology as your usage profile changes. You need to be able to plan for that. As adoption increases, hopefully, as more people start using SharePoint, start liking it, there's this kind of curve of adoption when users, you first deploy it and you turn it on and they get an email from the chief exec saying, we've got this wonderful SharePoint, go use it. Most end users hate it, right, initially, because they're used to just sending emails around with attachments. Now they've got to upload it to SharePoint and copy the link into an email. There's more clicks involved. But eventually, assuming that the thing's been done well, adoption starts exploding. And based on that, you will need to change, potentially, your topology. So don't get locked into this. We've got one project for the infrastructure, and it's going to keep us right for 5 years. Over 5 years, you need to make changes there. Have a couple of boxes in your back pocket, as it were, that you can add in or identify. Assume that this is going to change, and really think long and hard about whether you want to deploy this on physical kit. If you do it virtually, you have way more flexibility here than if it's on physical machines. Especially if you're a large organization, you have a hosting, either it's provisioned externally by a service, an outsourced service, or you have to go through the mill with an internal IT department. Changing the network address of a machine or something like that can take weeks, right? Change control and so on. Virtualization removes some of those barriers, makes it much more agile. Also think about future versions. It's interesting, we're here now today, we've got the RTM effectively of 2010. And if you look at this from a historical perspective, 2007 was a significant change from 2003. 2010 is a significantly different architecture, and there is way more in the product. Anybody want to hazard a guess what's going to happen with SharePoint 2020? I'm making a joke there. It's not going to take them 10 years. Well, we hope not. There's going to be more in 2020 than there is in 2010, right? And I'm not going to call it 2013 because it won't be called that. But Microsoft has a commitment to a 3-year product life cycle for these products. So within 3 to 5 years, we're going to have a new version. And you need to be thinking about it now. You don't need to be spending a lot of time thinking about it, but you need to consider what potentially is going to happen. You also need to think about operations management. It's often kind of stuck on the end of a project. How are we going to patch it? Can we patch it quickly? Can we avoid downtime? How do we report on usage adoption? It's all very well to say we need to change the farm because performance is slow, let's add another couple of machines in. But you need metrics to determine that decision. Now, if you're going to spend money on an extra license, which is not an insignificant cost, you need to be making sure that you're doing the right thing there. And so you need the metrics to justify that. And also think about the hidden cost of SharePoint. So this is all the stuff that you need that SharePoint doesn't give you, like antivirus. Okay, so our files are stored as blobs in the database, or if you're using remote blob storage on a file system, potentially, those are not going to be scanned by, you know, the little thing that's annoying you in the taskbar that's running on your servers. Because even if you're using RBS, that file doesn't touch. You know, it's going to be ignored by that solution. So you need a streaming AV solution if you care about protecting your users. Obviously, backup and restore. Perhaps you saw Chris's session. You know, the out-of-the-box backup and restore is pretty crappy. How many of you here run Exchange Server? Most of you. How many of you are using the out-of-the-box Exchange Server backup and restore tools? Yeah, nobody, right? You're either not backing it up, which is what I do in my house, or you're using some third-party solution for that. Same thing with SharePoint. Systems management, you know, doing event log correlation and so on, you're probably looking at something like Operations Manager, those kind of things. So usually these are stuck on the end of the project because the budget was done before you showed up, right? And then you're there and you say, oh, hang on, you need to think about backup and restore. And, oh, we haven't budgeted for that. You know, these are things to point out immediately the first day you're on the engagement. Scalability, just briefly, a lot of people say SharePoint can't scale. I have a case study here for 2007. We'll have a similar one of these in about 6 weeks for 2010. The numbers, it's basically the same message, the numbers are bigger. Average daily load of 5 million TIFF images, 2 million Office documents, 40 million items were loaded into SharePoint over 13 days. You can see the content database sizes there. All of them are bigger than the Microsoft 100 meg magic number, 100 gig magic number. 5 terabytes of content. And the way this was done was with this infrastructure. And there's a slight mistake on the diagram, but basically we have, ignore this box. This is the test kit that was done for the case study. We have 5 web front ends at the top. We have 1 query server, because this is a input-heavy environment. We have a machine running central admin, an index server, and we have a SQL infrastructure. So not that many boxes for 5 terabytes of content with some pretty impressive load times. And we're not talking about Word documents with 1 page in. We're talking about engineering diagrams here, TIFF images. And the way we scale SharePoint is not by adding more servers to the farm, but is by designing our data storage appropriately. So you can see here, well, you can't see very well because it's too small, but you can see the blue blobs are files, database files, and you can see they've been partitioned across different logical disks, or LUNs here. So by designing your SQL storage infrastructure, you can get this kind of scalability. And it's a bit of an advert for Jitsi servers. I'm not recommending them. It could be anybody else's. It wouldn't make any difference. The point here is it's all about how you do your SQL storage design. And here's just a pretty picture. Oh, when you get the decks, you can click the link that's hidden by the picture. But this is basically this farm at the point at which it can't scale any further. And you can see our average response times here on the top row the average is basically 3 seconds. So this is the point at which we now need to add more infrastructure. So we can do some, and this is, the 40 million items being pushed into the environment. And you see our processor time on the web front ends there is pretty good. Obviously, we've got a max of 100. We've hit that. But our average here, and it's like all the little red X's in the graph at the top, is where we're hitting the threshold, which is 98 or 97 in this case. So you can see the average processor utilization here is 90, 90, 91, 92, 89. That's good. That's why you buy processors. You want your processors to be 80% utilized. If they're not, you've got too many of them. All right? Now, you don't want them to be 98, 99 all the time. That means you need more resources. But you want your processors not quite this level, but a little bit less than this. That's a good state to be in. Very briefly, before we leave, the magic numbers. This is how many 4x I can have in my SharePoint. I'm not talking about dodgy Australian lager. This is how many site collections I can have in a web app, all those kind of things. And there's a document on TechNet called Plan for Software Boundaries. Got the two links here, the old one and the new one. You can see with 2007 we had memorable URLs, kind of. But because it's 2010, right, we've got a GUID, obviously, in the link, which makes it much easier to remember where it is. And I'll just show you this if you haven't seen it already. This is probably the most important document that you can reference in the short term as you're working with the product. They've given it a fluffy title there, capacity management, blah, 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 blah. And I just scroll down here, and we have we're saying here we have 10 application pools per server. That's why we can't have hundreds of web apps on a machine and so on. Our site collection size, and so on and so forth. Now, you'll notice that 5,000 is the new 2,000, right? So all before it, you say 2,000 is a recommendation. That's now 5,000. And, we can go through it. I'm not going to spend time going through it. The document also gives you a little bit of discussion around some of the limits. And it's a pretty big document. But you'll notice there's some things, well, when you read it, you'll notice there's some things missing. This is a work in progress. As we get feedback from field deployments, that's updated. But these are not hard limits. They are guidelines for acceptable performance. You can have, 5,005 items in a list, and if it's working for you, you're good. Right? These are guidelines. They are not hard limits. There are a couple of hard limits in terms of the higher level objects, but this is basically just guidelines based on what Microsoft have been able to test. In the original ones, the 2007 ones, the test scenario was a single database server and 1 to 8 web servers. But it was this stuff: team, document workspace, blogs, wikis. You notice there's no enterprise features there. There's no search. There's no Excel services, and so on and so forth. Because Microsoft, you might think they've got a bottomless pit of money and resource to spend on things. They don't. They're just like every other organization. They can't test everything. It's just not feasible. And they're probably not the right people to be testing all of it anyway. We want other people to deploy it and build these metrics. So over time, this stuff is added to, and over time, you can expect some of these numbers to change as well. So way back when, we had a recommendation that you could have 50,000 site collections in a web application. That number changed to 150,000 6 months later. So don't get too tied up on these. The real point here is there are no magic numbers. Oh, just on content database size, the new 100 gig is now 200 gig for collaboration scenarios. If you're a record center or something like that, you can go up to 1 terabyte, and that will be supported. But the message here is there are no magic numbers. You have to compromise. Based on what you're doing, you balance things out. You may go beyond these limits. That's okay. If you want to do a good job of building a SharePoint farm, you make that compromise play smartly, and you reduce complexity. Complexity is your enemy. It also means that you're the guy they call when something goes wrong. The more complex it is means the more difficult it is to give it to somebody else to look after. So you need to evaluate the solutions holistically. Look at it from across the board and make sure you factor everything in, make the compromises necessary. And it might sound weird, but you should actually test stuff and see how it plays out and change it based on the results of the test. You don't always have that luxury, I understand that, but you do need to be agile and change things up as usage changes. SharePoint is not a point solution like Exchange or SQL Server in many respects, where you can just put it in once, leave it, and it takes care of it for you, assuming you don't add another 50,000 users to the organization. SharePoint has ebbs and flows in usage and characteristics. And so that's me. Apologies for running over a little. I hope it was useful. If you have questions, come along to the Ask the Experts later this afternoon. Thanks very much.